All right, going over the Unit 4 bonding and naming test review. Some of this is topics we've touched on a little bit, and beyond that, just a little bit of other stuff as well. So based on the octet rule, which remember is just saying that every atom pretty much wants 8 valence electrons or electrons in an outer shell. Phosphorus forms a -3 charge, which means that it has 5 valence electrons. Which group does not form anions? Anions are negative. So everything that forms a positive charge, such as metals and transition metals, do not form anions. And noble gases, which are neutral, would also be considered groups that do not form anions. So non-metals are the only negative one. So they do form anions. Elements on the opposite sides of the periodic table tend to form ionic, because that'd be a metal plus a non-metal. Elements are both on the right side tend to form covalent, because that's non-metal plus non-metal. Okay, so charges. So I filled in valence electrons for you. Example, since phosphorus, as we said before, has 5 valence electrons, it forms a -3 charge. So just like that, nitrogen will form a -3 charge. Aluminum, which has 3, is going to get rid of those 3 to form a +3. Oxygen, which had 6, is going to gain 2 electron to form -2. Chlorine, which has 7, will gain 1 to form -7. Nickel, which has 2, will form a +2 charge. Magnesium, same thing. Nickel will actually form a +3 as well, because it's a transition metal. Argon has 8, so it'll form a neutral charge, and iron, which has 2, can form a +2 or +3 charge as well. Because again, the difference between nickel and iron compared to the rest of the metals is that they are transition metals. Why do elements form compounds or form reaction? Is it increases stability by getting a full shell of valence electrons. And that's what's happening here. Brittle solids, that would be covalent. Weaker bond is covalent. Low boiling point, covalent. Non-conductor is covalent. High melting point, ionic. Dissolves, ionic. Stronger bond, ionic. And conductors would be ionic. So based on those properties, what do we have here? A white powder that melts at 98, it's a pretty low temp, is brittle and described as non-conductor. Would have what type of bond? That would be covalent. Okay, formula writing. I'm writing the formulas here. So manganese, I'm just going to put an I or a C by all these. That's ionic, 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 covalent, ionic, 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 and covalent. Okay, so that's based off of the first element. Remember, the first element being a metal determines whether or not something is a ionic or covalent. So manganese, in this case, Mn, is a +4. Oxygen's a -2. I crisscross and reduce. I get Mn2O4, but when I reduce that, I end up getting MnO2 because the 2 and the 4 reduce. Okay, I'm going to zoom in a little bit here just so I have a better time writing. Beryllium is Be +2. Nitrite is N-3. So when I crisscross, remember ionics, I crisscross, I get Be3N2. Okay, oops. Strontium is Sr, it's a +2. Sulfate is a polyatomic ion, SO4 -2. Like charges cancel, so I just get SrSO4. Sulfur hexafluoride, no prefix tells me I have 1 S. Hexafluoride means 6 Fs. Silver is Ag +1, Cl -1. I crisscross them, I just get AgCl, like charges cancel. Nickel is Ni, it's a +3. Arsenate is AsO4 with a -3 charge. Like charges cancel, I just get NiAsO4. Strontium sulfate, that's a double, so that's the same thing here. Tungsten, phosphide. Tungsten's a +6. Phosphide's a -3. Crisscross, I get W3P6. But those reduce, so I get WP2. Okay, so that one's already done. Disulfur means 2 sulfurs. Pentachloride is Cl5. Oh, that's a typo there. All right, so that's formula writing. Choosing whether ionic or covalent. Okay, so naming. Look at your first thing. Is it ionic or covalent? This is ionic. That's ionic. Covalent. Ionic. 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 Most of these are ionic because that is the most difficult thing for us to do. Covalent, ionic, and covalent. Sorry, that's ionic. Okay. So in ionic, you just say, what is your first element? So Na is sodium. And then what is this attachment? So I'm looking for C2H3O2. And that is called acetate. I'm just looking at my periodic table. Okay, that's it. CS is cesium. Oxygen is IDE oxide. This is covalent because phosphorus is a nonmetal. That means this is diphosphorus. Pentoxide. It's 5 oxygens. Okay, covalence is just the prefixes. Again, pause at any time if you need to. V is vanadium. When I look at the periodic table, though, I see vanadium can form a +3 or +5. Okay, so then I have to figure out what ClO2 is. So as an example, if I go back to my periodic table here, boom, ClO2 is right here. It's chlorite. Okay, so it's a -1 charge, which means vanadium is going to be a 3 or 5 right here. And based on chlorite being at a -1 charge, I know that I'm going to use my charge of 5 for vanadium. Oops. Because I see the 5 here, that came from the vanadium. And then this is chlorite. Okay. Similarly, here nickel can be a +2 or a +3. Since Cl is a -1, I know that nickel has to be a, nickel has to be a, come on now, +3 in order for that to happen. So that means it's going to be nickel 3 chloride. Li is lithium, and it's a +1 charge. It only has one possible charge, so I don't need parentheses. So I'm looking for what PO4 is, which is phosphate. It's a polyatomic ion. Again, one of the keys for identifying polyatomic ions is if my first element is a metal, everything after that is a polyatomic ion. It's like SO3 down here. Okay, you compare that to like just S there. Okay, that's the difference, is I only have one element. Okay, so here we have copper. Copper can be a +1 or a +2. Okay, so based on this, copper is going to be a +1 because Se is a -2 charge, which means copper has to be a +1 to get this formula. So it's copper 1 selenide. Rb is rubidium. It only has one possible charge. S is sulfur with an IDE, which is sulfide, so I get rubidium sulfide. Okay. Na is sodium. SO3 is sulfite. Oops, that's an O. With an ITE ending. (4As) is tetra arsenic. And 10 oxygens is dec oxide. It's covalent, so it's prefixes. Ag is silver. It only has one possible charge, so I don't need parentheses. And then my polyatomic ion, CO3, is called carbonate. Okay. Ti is titanium. It's going to have some type of charge here. NO3 is nitrate. And when I look on my list, NO3 is a -1 charge, which is why this 4 right here came from the titanium. So that's the charge of the titanium that I'm using, is titanium 4 nitrate. Okay. Let me know if you have any questions. How many total atoms are in this atom? I have 2 NAs, I have 1 C, I have 3 O's for a total of 6 atoms. That one's pretty obvious. Fe, I have 2, but I have to distribute this 3 like math, so multiply. That's 3 S's, and 3 times 3 is 9 oxygens. So that would be 14 atoms. Okay, so based off of this, I'm looking at this compound to identify if it's ionic or covalent. Write the chemical formula, and then label each. I'm not really sure what I meant by that. But here there's 2C, so it's C2H6. So the name of it, so it's covalent because you have 2 nonmetals. So it'd be dicarbon hexahydride. And if you remember from our organic chemistry, it's also 2 carbons. So this would be also ethane, would be an acceptable name as well. And that's it. That's what we got here. If you feel good about this, you should do well in the test this week. And that's it. All right. Love you guys. Bye.